Hello and welcome to another episode of BioCT's Stories Behind the Science. My name is Peter Propp. Today, our guest is Nicole Wagner. She's the CEO of LambdaVision, a company with a powerful tagline of helping patients regain sight. Nicole, thanks for taking the time to talk today. Can you please tell us about LambdaVision and your role at the company? And importantly, how does LambdaVision intend to help patients regain sight?
Thanks, Peter. So as you said, my name is Nicole Wagner. I am the president and CEO of a University of Connecticut spinoff company called LambdaVision. LambdaVision was developed to help patients that are blinded by end-stage retinal degenerative diseases, so diseases like macular degeneration and retinitis pigmentosa, regain sight. And so the way that we are currently doing this is through by using the light-activated protein bacteriorhodopsin to be placed on a scaffold that then can be inserted into the back of the eye to help patients regain sight. So just to give a little bit of background on how these diseases work, because then it might help make a little bit more sense of how we're doing this. So if you are a patient with retinitis pigmentosa or macular degeneration, the light sensing cells in your eye, so these are your rods and cones, they start to die. As those cells die, your eyes become incapable of taking light energy in the room, like the room you're in right now, and converting it into a signal that can be sent to the brain. So what we do is we use a light-activated protein. That's that protein bacteriorhodopsin. We coat it on a scaffold. Think of that scaffold like a really tightly woven piece of gauze. We put that in the back of the eye where those cells would exist, your rods and cones. And now the protein absorbs light. It's going to convert it into a signal that can then be sent to the optic nerve and the brain.
And that gauze is micrometers. What's the thickness of that gauze?
You know, I think we're even talking angstroms, like 30 angstroms. This is really almost, think of it like a hole punch, right? If you had a little piece of paper, and this is actually purple colored, so a purple piece of paper that you punch a little hole through, that's what you would be inserting into the back of the eye.
It's amazing. So the other part that's exciting about the LambdaVision story is that you're developing this artificial retina technology really at the cutting edge of low Earth orbit manufacturing. So can you talk about the process you developed and how you got to work with NASA, which is a very exciting whole story?
Yeah, this is actually a really fun story to tell. So if you asked me many years ago if I thought I'd be in space, the answer was absolutely not. So we actually were started our work in microgravity after being awarded or entered into this accelerator program called Mass Challenge. So for those of you who don't know what Mass Challenge is, it's a program in Boston that was designed to help startup companies really help get them off the ground. You build a business plan, help you raise funding. But one of the sponsors there was CASIS and Boeing. CASIS, for those of you who don't know, is the Center for Advancement of Science in Space. So one day I was driving from West Hartford, Connecticut to South Boston, so about 2 hours. I was sitting down at a table and somebody knocked on the table and said, "Hey, by the way, these people, CASIS are here, Boeing's here. There's some free pizza down the hall, and let's hear what they have to say." But literally, I'm sitting there looking at my watch, like, I got a couple hours to kill. Ended up going to the presentation, expecting to hear about the moon and Mars. Did hear a little bit about that, but also heard very much about what the ISS National Labs is doing to help patients on Earth. So at this time, there was a lot of biomanufacturing, a lot of bioprinting. And for us, what we were able to do is think about how we can make that connection with printing proteins or scaffolds or inks onto some sort of scaffold, and then applying it to patients terrestrially. So fast forward, we actually won that prize in 2016. We flew our first experiment on SpaceX 16 at the end of 2018. And the story I tell people is it was so wild. We get to be SpaceX VIP from a private launch location. Really, it was just amazing to see our payload go to the International Space Station. So just a really wild experience. But just to take one quick step back here, the other part is it's really great to do things in space, but why? And I think that's really important for the audience to hear. So the way that we currently manufacture this artificial retina on Earth is through a process called layer by layer electrostatic deposition. That is a mouthful, I'm sure. But think about having 6 glasses of water on a table. And we have, again, that really tightly woven piece of gauze floating on top of glass number 1. We then take that gauze and we move it to glass 2, 3, 4, 5, and 6 before doing it again 200 times. So you can imagine on Earth, everything in that glass is going to be subject to the effects of gravity. Things like sedimentation, homogeneity, evaporation, convection, surface tension are all going to play a role in how that protein is going to deposit onto that scaffold. So you can imagine if you had an imperfection at layer 50, that it's going to be compounded by the time that you're at layer 200. In microgravity, your molecules are all nicely even spread out. You get much more homogeneous binding, better layering, and ultimately a much more stable product. So today we've flown 8 missions to the International Space Station. Really, really cool. We are flying our 9th mission at the beginning of this year, or at the beginning of 2024, rather, and are just excited because we think there'll be many more flights in our future.
Right. And I've seen the manufacturing setup that you created that goes on to the satellites. Can you just talk about the size of it, how that was developed, and how you developed this remote process?
Absolutely. So we, of course, when we very first started at being a space Earth company, thinking about how we do things terrestrially, I sat down and I was like, how do we get this to space? I mean, we had a big, huge dipping apparatus. This apparatus probably took about the entire space of a desk.
Mm-hmm.
It was an open beaker system. We worked with an implementation partner. So for those of you who don't know what an implementation partner is, they're sort of the middleman between a company and getting to the ISS. But what this person did, this group did, this is the group we worked with Space Tango. They helped to miniaturize that open beaker system to about the size of a shoebox. And in that shoebox, we can make approximately, I would say, 50 implants. That then we take that shoebox, we plug it into power on the ISS. That comes down, we disassemble the package, the films come to us, and then we analyze them.
Right. So we're really off our script here, but it's fascinating. So when you're in production down the line, that you're going to be sending up a series of these shoe boxes on a regular schedule. They're going to go up, they're going to go down, and that's the way you're going to manufacture everything that gets introduced to humans.
Yeah, so I mean, right now we're still in our R&D phase, right? So certainly developing the technology, but where we are right now also is very much thinking about scale. How do we take the current this current design? Like I said, it's about the size of a shoebox. It's actually called a cube lab, and be able to sort of scale that up. One way we think about scale is maybe sending many of those boxes to the ISS or these commercial LEO destinations. So these are these private space stations, or do we? In terms of thinking about this, do we, lighten the mass of this? Can we make more implants in an individual shoebox? I think there's a lot of different ways that we can start to think about this now. But, where we are is kind of how do we use the ISS National Labs as a test bed and then transition from that test bed to these commercial LEO destinations or private space stations in the future.
Exciting. So, we got about 6 minutes to go. I know you are a proud UConn alum. I'm a very proud UConn parent. Can you tell us about how you became interested in a career in science and the role that UConn played in the origin story of LambdaVision?
So for me, it's a very serendipitous path. I think there's many people that could probably relate to starting off at one point and ending up very different, in a very different point. But for me, I was a graduate out of a high school, Oxford High School in Massachusetts. As a young kid, I had scholarships to a lot of schools in Massachusetts. And I said, you know what, hey, I want to do something different, like most young kids want to do. And I said, I'm going to go to Florida State. I went there for a year with the goal of becoming a physician. My reasoning for becoming a physician wasn't necessarily, I always wanted to help people. I knew that was something that was really important to me. But I didn't know what a scientist was. I mean, I think a lot of people can identify with a doctor, a nurse, a school teacher. When you think about a scientist, you think of like Bill Nye the Science Guy, or, these really kind of crazy, outlandish people. But at the end of the day, these are really a lot of scientists are your normal day-to-day people that are really trying to do something translational. So anyways, I'm at Florida State, and a year there was great, but I got homesick. So I transferred back after a year. I ended up going to UConn, where the only reason I actually joined a research group was to check a box on a medical school application. Literally, hey, I did research, and that was it. So I joined the group of Bob Birge, which is actually where the LambdaVision was founded out of. And first year, I cleaned a lot of glassware. Second year I was there, I said, hey, can I do a little bit more research, which I was able to do. And then it came to time for me to decide, do I go to medical school or do I stay and pursue a career in research? And at the time, Bob Birge was like, Nicole, I think you'd be great at research. You should really stay. So I put all my eggs in one basket. Didn't apply to medical school. I didn't apply to any other graduate schools. And this is 2007. Let's remember. And I actually didn't get in. So that first year was a real bummer for me. But I was very fortunate that Dr. Birge and his wife Connie were very, very supportive and helped me get through that first year as a sort of a bridge year. I reapplied in 2008 and actually got into the Ph.D. program. And for me, that was really what kicked it all off. So I started off in science there. I started off optimizing light activated proteins for devices. The technology, artificial retina, was formed out of that lab. I then, there's only so many times that you can do a PCR reaction or change conditions before you think you're going to go crazy. So when the opportunity to start the company came up, it was great. And it gave me an opportunity to really leverage a lot of the other things that I enjoy doing, which is talking to people, translating the science that I learned into something that could potentially be commercialized. So I am now, the company is spun out of the University of Connecticut. We're located in Farmington in the incubator program there.
Amazing. Switching gears again, I know you have a young family and your husband's a busy physician. How do you navigate the challenges of running a company and being a mom?
It's not easy. So many people say, I just don't know how you do it. And what I will say to everyone is that it does take a village. I have friends and family that certainly help me out there. But what I would tell anybody watching this, if they have kids, know that I have dishes dishes in my sink. I have dirty laundry. I have laundry to be folded. I have, a half-eaten dog, a cushion that was eaten by my dog. So I'm just like anyone else. And the other thing I guess I would add here too is it's hard to find that balance, right? So when I think I'm doing great at my career, there's usually something that's, I'm missing something at home, or if I'm at home, I feel like I'm missing something in my career. I'm not being at the top of my career. And so that balance just, I don't think you'll ever really achieve it. Right. But you just got to do one thing, know also that your kids are looking at what you're doing, and they're watching you. And so keep moving forward. There's not a perfect scenario for success.
Right. I'm sure your kids are super proud of your work also.
They definitely are. My daughter went to school in kindergarten and said, Mom, when how parents are really proud of their kids. And I said, yeah. She said, well, today you're going to be really proud of me. And I said, why? She said, well, I helped NASA. So she definitely made that connection of what I'm doing to the work that she's doing. And that was really, that's always been something that's really important to me is watching her grow up and, watching her mom too, do a lot of things.
Amazing. So that's just the final question. So, and we could go on forever. You've got a great story. Talk about LambdaVision in terms of where you are in development and when we can expect to see LambdaVision products helping the general public.
So right now we are in preclinical development. So we are doing a lot of testing to help support development of our product to get to patients. If all goes well, we expect that we could be in the clinic in about 3 years. And right now we are actively raising a seed round to help us get to IND, and we hope to be able to close that at the beginning of the new year in 2024.
Excellent. Well, Nicole, thanks so much for your time today. I know people will get a lot out of your story, so I really appreciate it.
Thanks a lot, Peter.